Now let us solve some numericals based on Newton's universal law of gravitation. How does the force of gravitation between the two objects change when the distance between them is reduced to half? Now in this question, let we take two objects having mass m1 and m2, having distance d between them, then according to universal law of gravitation, the F is equals to g m1 m2 upon d square, where F is the force between the two objects m1 and m2, g is the universal gravitational constant, and d is the distance between the center of the two objects. Now in this question it is given that how the force of gravitation between the two objects change when the distance between them is reduced to half. Now what we are doing is, the mass is same, we are reducing the distance to half. So let us take the new force, that is F dash, denoted by F dash, g m1 m2, because mass is not changed, only the distance is reduced to half. So we will write half d square. So F dash, that is the new force between the two objects, will be g m1 m2, and when we solve this, the square of half d will be equals to 1 upon 4 d square. So F dash will be equals to g m1 m2, and this is 1 upon 4. When we take it up, it will become 4 upon 1, that is 4 g m1 m2 upon d square, that is equals to 4, and this g m1 m2 upon d square is equals to force. So the new force, that is the force, will become 4 times the original force when the distance is reduced to half. Let us solve the second question. What happens to the force between two objects if the mass of one object is double? Here we have seen two objects having the mass m1 and m2, and distance between their centers is d. According to universal law of gravitation, the force between them is given by the formula F equals to g m1 m2 upon d square. Now if we double the mass of one of the object, let's say we will double the mass of the object m1, so in that case the new force between them will be equals to g, and here we have double the mass of the first object, that is 2m1 m2 upon d square. That can also be written as 2g m1 m2 upon d square, and this g m1 m2 upon d square is equals to force. So F dash is equals to 2f. So that means the force, if the mass of one of the object is double, then the force will be 2 times the original force. Now let us solve the third question. What happens to the force between the two objects if the masses of both the objects are doubled? So we know that according to the universal law of gravitation, the force between the two objects is given by g m1 m2 upon d square. Now in this question it is given that masses of both the objects are double. That means this is also double and this is also double. So the new force between the two of them will become g. This will become 2m1, and here it will become 2m2 upon d square. So 2 into 2 it will become 4. So F dash will be equals to 4 g m1 m2 upon d square. So you can see here this g m1 m2 upon d square is equals to F. So the new force, that will be 4 times the original force between m1 and m2 at a distance of d. Now let us solve the question number 4. What happens to the force between the two objects if the distance between the object is double? Now we know that F is equals to g m1 m2 upon d square, where m1 and m2 are the masses of the two objects and d is the distance between their center, and g is, capital G is universal gravitational constant. Now in this question it is given that the distance between the two objects is double. So let's see what will be the new force. That will be equal to G m1 m2. Here the distance is double. So earlier the distance is d. So when it is double, it will become 2d square. Now let us solve this. This will become f dash is equals to G m1 m2 upon 4d square. That can be written as f dash is equals to 1 upon 4 G m1 m2 upon d square. That means the new force is 1/4 of the original force.